All right, continuing on with lesson 2.4, we're factoring polynomials in quadratic form. So for these, we need to figure out what pattern we're looking for, right? So when I see a binomial, so that's two terms, I want to figure out whether it's a perfect cube or a perfect square. And I've got the perfect squares memorized pretty well, so I'm thinking it's that. But I have to figure out what our two squares are. So I know that 16 is 4 times 4. So I have 4x squared times 4x squared. And 81 is 9 times 9. So this will give me the difference of perfect squares, where I'm going to have 4x squared plus 9 and 4x squared minus 9. But what's interesting here is I have perfect square again. Difference of squares, 2x times 2x and 3 times 3. So that second binomial I can factor again, because remember, we're factoring completely here. So here I can do 2x plus 3 and 2x minus 3. So that is my factor completely. It's just interesting how, like, when we think we're done, we're really not. We can go again. All right, let's try another one. So the instructions, again, are factor completely. So I think I can factor out a monomial first. So let's go ahead and take out a 2, because everything's even. So I know I can take out a 2 and a p squared. What I have left is p to the 6th power, 5p to the 3rd power, and 6. Now what can I do with that trinomial? Okay, that trinomial actually factors into two binomials. So let's look at it. I've got a times c is 6. So I need two things that multiply to 6 and add to 5. 2 times 3 multiplies to 6 and adds to 5. So I can go p to the 6 plus 5, nope, sorry, 2p to the 3rd, 3p to the 3rd, 6. And then I can factor by grouping. This first one, I can take out a p to the 3rd. I have a p to the 3rd plus 2 left, and a 3, p to the 3rd plus 2. So now I'm going to group those, p to the 3rd plus 2, and p to the 3rd plus 3. That's not too tricky, because we've learned how to factor by grouping, which makes it a bit easier. All right, now some guided practice. So this is reviewing examples 3 and 4. We covered example 3 in the last video, and we covered example 4 here. So the first few are going to be a factor by grouping. So I group and I group. Take my greatest common monomial out, which is an x squared, and I'm left with x plus 7, and then a minus 9, because whenever it's a minus there, I factor out the negative, and x plus 7. So I get x plus 7, x squared minus 9. Look at it, see if you're done. Here I'm not, because I have a difference of perfect squares again. So x plus 7 and x squared minus 9 factors to x plus 3, x minus 3. And now I'm done. Here I have the difference, and let me grab a calculator. I don't think I can take 16 out of 625, and I don't know if 625 is a perfect square because it's a big number I don't have memorized, so I need to check it. Yep, 625 is 25 times 25. Ugh, sorry. 25 times 25, and 16g to the 4th is 4g squared times 4g squared. So I have the difference of perfect squares. I'm going to do a different color so I don't get confused. 4g squared plus 25, 4g squared minus 25. And I have the difference of perfect squares again. I can split this up into 2g times 2g, and here into 5 times 5. So 4g squared plus 25, and 2g plus 5, 2g minus 5. Factor completely, right? All right, this last one. Let's take out my greatest common monomial, which looks to be a 4t squared. I'm left with t squared minus 5t. Oh, I see my mistake. T to the fourth power, 5t squared plus 6. And then a times c is 6, so two things that multiply to 6 and add to negative 5. Negative 2 times negative 3. I'm going to run out of room. Okay, we're going over here. Changing colors. My monomial, and then t to the fourth minus 2t squared plus, minus 3t squared plus 6. Factor by grouping. 4t squared. Now factor out my monomial, which is going to be t squared, and I'm left over with t squared minus 2 and minus a 3, t squared minus 2. So I've got 4t squared, t squared minus 2, t squared minus 3. Final answer. Okay, little reminding, solving polynomial equations. You've learned how to use the zero product property to solve factorable quadratic equations. You can extend this technique to solve some higher degree polynomial equations. Okay, a little bit of a reminder. We would have fun equations like this, which I would say solve, find the solutions, find the zeros. Solve, find the solutions, find the zeros. Graphically, it's where we would have a parabola, and where it crosses the x-axis are our solutions, our solving, and our zeros. Okay? Algebraically, we take each binomial, set it equal to 0, and solve for it. Amazingly enough, it's where our parabola crosses the x-axis. It's our solution. Okay? It's our 0, because it's where y equals 0. It's our solve. We can only do this when we have an equation equal to 0, right? So let's try it with harder equations. What are the real number solutions of the equation given? When I say real number, that means I'm not going to talk about anything with an I or anything irrational. Okay? Real number solutions. So first we have to put this in standard form. So that means the highest polynomial to the lowest polynomial. I'm going to subtract 18 from both sides, and that leaves me 18x cubed plus 15x equals 0. And factor out the greatest monomial. Looks to be a 3x, and I'm left with x to the fourth minus 6x squared plus 5. Now I need to factor that trinomial. So a times c is 5. I need two things that multiply to positive 5 and add to negative 6. I think negative 1 times negative 5 is right. So x to the fourth minus x squared plus, minus 5x squared plus 5. Factor by grouping. I get 3x. I'm going to factor out an x squared. I'm left with x squared minus 1. factor out of 5, x squared minus 1 equals 0. I'm going to a new slide, but you guys are taking notes, so you should be able to follow along. So I factor that, I'm going to get a 3x, x squared minus 1, x squared minus 5 equals 0. Well, this binomial is a difference of perfect squares, so I can keep going. X squared minus 1 factors to x minus 1, x plus 1. Okay, now we're done. It's factored completely. We can find the solutions. It's called the zero product property. That means anything times 0 equals 0. What that means is any of these pieces, if anything here is 0, then the whole equation is 0. So I've got lots of OR statements here. 3x equals 0. Divide both sides by 3. X equals 0. Or maybe x plus 1 equals 0. Or x minus 1 equals 0. Or x squared minus 5 equals 0. X squared equals 5, not quite done yet. X equals plus or minus square root of 5. So my answers are 0. Well, usually try to put it in order of smallest to greatest. So -1 or 0 or 1 or plus or minus square root of 5. What's really, really important here is your original equation. If you look at it right there in front of you, the degree is 5, so I should have 5 real solutions, or 5 solutions. 1, 2, 3, 4, 5, because my degree is 5. Okay? It's a great way to check that you got them all. All right, let's try a practice. Find the real number solutions to the equation. My greatest common factor, greatest common monomial, is going to be 4x. And I'm left with x to the 4th minus 10x squared plus 9. A times c is 9, adds to -10. So -1 and -9 multiplies to +9, adds to -10. So factor by grouping, minus 1 x squared minus 9 x squared plus 9. Okay, first two terms, second two terms. It can factor an x squared out of that first one. I get x squared minus 1 left, and a -9 x squared minus 1. Keep going. X squared minus 1 and x squared minus 9. I have the difference of two squares twice, the difference of perfect squares twice. So this first binomial factors to an x plus 1, x minus 1, x plus 3, x minus 3, and I have 5 solutions. So this first one, x equals 0, x equals -1, x equals 1, -3, and 3. It's a 5th power, so my degree is 5, and I have 1, 2, 3, 4, 5 solutions. Find the real number solutions. To put this in standard form first, 2x to the 5th minus 14x cubed plus 24x. And factor out our greatest common monomial, which is a 2x. 7x squared, 12. A times c is 12, so two things that multiply to 12 and add to -7. 1 times 12, 2 times 6, 3 times 4. So a -3 and a -4. So minus 3x squared minus 4x squared plus 12. Factor by grouping. 2x, let's see, I can take out an x squared from that first one. I get x squared minus 3. I can take out a negative 4x squared minus 3. So 2x, x squared minus 3 is common. X squared minus 4 is left over. Looks like I have a difference of perfect squares again. X squared minus 4 is the difference of perfect squares, so I get x plus 2, x minus 2. Zero product property says 2x equals 0, therefore x equals 0. X squared minus 3 equals 0. X squared equals 3. Square root of both sides. X equals plus or minus the square root of 3. So that's 1, 2, 3 solutions, because that's 2 solutions for that one. And then here I have x plus 2 equals 0, therefore x equals negative 2. X minus 2 equals 0, therefore x equals 2. So I have 1, 2, 3, 4, 5 solutions. I just realized I don't know why that says that. So this isn't a warm-up exercise, sorry. Last one. Let's put it in standard form. So biggest number to smallest number, I'm going to move that over there. Add 6x to the 4th to both sides. Minus 27x cubed plus 15x squared equals 0. Factor out my greatest common factor. I think it's a 3x squared. I'm left with 2x squared minus 9x plus 5. That seems right. A times c is 10. So I need two things that multiply to 10 and add to negative 9. Let's see, 1 times 10, but it's positive. 2 times 5. That stinks. So what do we do if we can't factor it? Use the quadratic formula. Bah, I know. All right, so I have A is 2, B is negative 9, and C is 5. So negative B plus or minus B squared minus 4 times A times C all over 2A. Calculator out. 81 minus, so negative 9 squared is 81, minus 4 times 2 times 5. So I have 9 plus or minus the square root of 41 over 4. I actually can't simplify that at all. So I have x equals that. And don't forget about this up here. 3x squared equals 0. X squared equals 0, therefore x equals 0. So it looks like I need 4 solutions because my degree is 4. This one right here gives me 2 because I have plus and minus, so 1, 2, and this one right here counts as 2 because I had x squared equals 0, so that's 2 of them. All right, that one's a little tricky. You are designing a marble basin that will hold a fountain for a city park. The basin's sides and bottom should be 1 foot thick. Its outer length should be twice its outer width and outer height. So width and height are the same, length is 2 times that. What should the outer dimensions of the basin be if it's to hold 36 cubic feet of water? So my area, my volume is cubed, So it's length times width times height, and it's going to be equal to 36. Now, if we look at each thing, each length, width, and height, this is x, but the inside of it is really x minus 1 minus 1. So I'm going to say this is x minus 2 because of the thickness of the wall. And my length isn't just 2x, but it's 2x minus that is what I want the inside to be. So let's erase this. I really want this part, which is going to be 2x minus the thickness. So we're going to say that is 2x minus 2. And then the height, which is x, minus the bottom, which is going to be 1 foot. Okay, that's a little tricky. So x minus the bottom thickness. So I have all of my binomials. Okay, I need more space now. So I know the volume is 36. And I know that I want the interior length, which we said was 2x minus 2. The interior width, which was x minus 2, and the interior height, which is x minus 1. Right? Let's FOIL these guys together. First times first, outer times outer, inner times inner, and last times last. Simplify that to x squared minus 3x plus 2, and then I need to multiply it by this one. Two x minus 2. So multiply the rows and the columns. I get 2x to the third power, 6x squared, and 4x. Then negative 2x squared, positive, I don't have to write positive though, 6x and negative 4. Collect like terms, 2x cubed minus 8x squared plus 10x minus 4 equals 36. I need to set it equal to 0 if I want to solve for it, right? So this, what I need to do to solve for x is I need to set my equation back equal to 0 and refactor it, which makes it the longest problem on the face of the planet. Not really, but you know what I mean. So I have to refactor this so that I can figure out what x equals. So I need more space. So I have 2x cubed minus 8x squared plus 10x minus 40 equals 0. Remember, when we have 4 terms, we want to factor by grouping. So factor out from your first binomial 2x squared, and I'm left with x minus 4. And then factor a positive 10, x minus 4. Factor out the x minus 4, I'm left with 2x squared plus 10. Now, zero product property says that x equals 4. Well, let's show our work. I have x minus 4 equals 0. Therefore, x equals 4. Or 2x squared plus 10 equals 0. Divide by 2. I have x squared is negative 5. I square root of that, and it's an imaginary number. I would have I root 5, actually plus or minus I root 5, which isn't possible because it's not a positive number I can measure with. So what we learned here, the only real solution is x equals 4. So the basin, x equals 4. So the basin its length, TH, goodness, I can't spell length, Length, was, from the beginning, 2x minus 4. So that's going to be 8 minus 4, so just 4. The width was x minus 2, so 2. And the height was x minus 1, which is 3. 4 times 2 is 8 times 3 is 24, not 36. Oh, hold on. Ha! It's 2x minus 2. So 2 times 4 is 8. Minus 2 is 6. 8 minus 2 is 6. So 6 times 2 is 12 times 3. Ha! 6 times 2 times 3 is, in fact, 36. Whew. I'm not sure why that was so difficult. Here's some extra problems I'm going to write the answers for. They'd be good ones to practice for the next assessment. I could use them, but I'm not going to work through all the work because the video is already long and some of you are ready to begin your homework. So you can save these as problems to practice. Like I said, I can put them on an assessment. 9 feet by 12 feet. Good job. Later.